sum and difference formulas, and I don't think that you need to write these into your notes because you have them on your formula sheet, but you'll notice there's sine, sum and difference formulas, there's cosine, there's tangent. We will probably stay away from the tangent ones in this class, but I just wanted to make sure I pointed those out on your formula sheet. The sine ones, what you'll notice, first thing I guess you notice is that you cannot distribute a trig function. That does not make sense. So you can't just say sine u plus v is sine u plus sine v. Instead, what you'll notice is the sum and difference formulas have sine and cosine in them. So how am I going to memorize this? Well, you need to look for patterns. Do you notice that the sine formula starts out sine u, sine, cosine v, sine u, cosine v. And then the sine matches the sine in the formula. And then it switches to cosine of, you already took v, so now you take u. Sine, you already took u, so now you take v. Same with the second one. Again, noticing the patterns here, cosine u plus v, this one, both of these formulas are cosine starting. And I notice that they have the opposite symbol. And then sine of the two. So again, how do you memorize those? We're going to look at the patterns, maybe write them down a couple times. But how you use them is making where we know sine of 30 degrees, sine of 60 degrees, we know those. We have to know those. We've had several quizzes on those. But for our first example, sine of 15 degrees, that is not one that you know. So what I want you to do right now is I want you to come up with two angles either added together or subtracted together. That's 15, but those two angles need to be of angles that you know. So think about this for a second. What two things add together to be 15 or subtract to be 15? And they have to be either 30, 60, 45. I guess you could go into other quadrants, but it would be easier if I can just use my first quadrant, 45, 60, and 30. So hopefully you've had a chance to think about that for a second. And what I just did was, in my mind, and there's multiple correct answers here, but I thought 45 minus 30. So what I'm going to do is I'm going to rewrite this problem. So the goal of this is to do this problem without a calculator. So sine of 15 is the same as sine of 45 minus 30. Because again, 45 minus 30 is still 15. So when we look at the formula, the u is going to be this 45. The v is going to be the 30. So if I go ahead and write the formula again so that you can see this, sine of u plus v, and some formulas, some textbooks use an a and b instead of a u and v, is sine of u cosine of v, the sine matches, plus cosine of the other one, so u, and sine of the other one, so v. So what we're going to do is we're going to replace this with the numbers. Sine of 45 times the cosine of 30 plus the cosine of 45, the sine of 30. So what we're going to do is we're going to continue this problem without a calculator. Sine of 45 should be one that you know. So think about that for a second. It should be one without the triangle, but if you need the triangle, 1 root 2. Although I'm going to write it as rationalized. I'm not going to write it as 1 over root 2. I know that that's root 2 over 2. Times cosine of 30. So again, think about your triangle or what you have memorized. Cosine of 30 is adjacent over hypotenuse. That would be root 3 over 2. Plus cosine of 45, we know that one, root 2 over 2. Plus sine of 30, opposite over hypotenuse, 1/2. Let's go ahead and multiply this together. Root 2 times root 3 is root 6 over 4. Root 2 times 1, and by the way, I did not write a multiplication symbol right there. I apologize for that. So root 2 times 1 is root 2 over 4. This would be your, and I apologize, I made another mistake, and I wish I could go back on the video, but I can't, so hopefully you've been yelling at me for quite some time. I went and wrote the plus formula. However, the whole problem was supposed to be minus. So I apologize for that. So we need to do a couple fixes. But this is really good because now you know that if it's a minus, we need to make sure it matches. So unfortunately, I need to fix a couple things. So this was supposed to be minus. This is minus. This is minus. And this is minus. And this is minus. Again, I apologize for that. And unfortunately, I'm not there, so you're watching the video, and I made that mistake. Again, it was minus. So when we look at this, the final answer is root 6 over 4 minus root 2 over 4. And you can leave that just like that, or you can write root 6 minus root 2 all over 4. If you wanted to even pick up a calculator, and by the way, all this red screen that you're seeing probably on the video is my calculator or my computer screen going bad, I'm afraid. Root 6 minus, let me actually get out of that square root, minus root 2. Now I wouldn't do this, but just so that you can see, if I hit Control Enter to get a decimal, it looks like that's approximately 2588, approximately 2588. So again, all these answers would be appropriate. I would probably just have left it right like this. So remember, the whole goal of this, and I apologize, remember the angle I used was 45 minus 30, so the formula needed to be minus all the way through. Hopefully you were yelling at me, and maybe even the sub pointed out, oh, she made a mistake. Good thing I caught the mistake. So what I want to do is just take the calculator and do sine of 15 degrees, and let's just see what we get. So if we do sine of 15 degrees, and let's use my trig button, sine of 15. Now, I probably have my calculator in radian mode because I've been practicing with radians, so I'll go ahead, instead of switching my mode, I'll use my degree button. And I'm not going to hit control, well, I'll hit control enter the first time so that we see. Okay, now I think I hit just enter. I have 3 square root of 2 times root 2. Now, look at that just for a second. Square root of 3 minus 1 times root 2 over 4. Distribute that. That would be square root of 6 minus square root of 2 over 4. So the calculator kind of factored it, which is the same answer that I have. Now, I don't think I hit Control Enter last time. Now you see I got the same decimal answer. So, same answers all the way across. The point of this was you were able to do this problem without a calculator. So the sum and difference problems will help us do this without a calculator. Okay, so let's do one more, and then we're going to do a different example based off the same material. Okay, we have 7 pi over 12. Cosine of 7 pi over 12. Now you could, if you wanted to, turn that into degrees and do the whole problem related to degrees. I don't care. I'm fine with that. Although, for notes here, I'm going to leave this as a radian problem. So what we need to think about is 7 pi over 12. What plus what is going to be something that we know? Now, I know that if it's a 12 as a denominator, that's my common denominator. So the chances are pretty high that this is a 3 and a 4. And we know that if we think about the 3 and 4 as denominators, we're probably talking about pi over 3 and pi over 4. So if I'm over here thinking on my side, pi over 3 plus pi over 4, is that really 7 pi over 12? Let's check. This would be 4 pi over 12, because you're going to multiply this by 4 over 4. This would be 3 pi over 12, which is 7 pi over 12. So I was able to come up with 2 angles, actually 2 angles that I know. Again, if that was hard, what you might want to do is just take that, okay, what is 7? Well, if we were still doing it without the calculator, maybe we'd have to figure out 7 times 180 divide by 12. What is that as an angle? Because a pi over 12 might not be one that you know. If I go ahead and just use my calculator for a second, and I say 7 times 180, and I divide by 12, I get 105. So 60, so 105, plus 45 is 105. So again, we really do, the point of this is to do it without a calculator, so that makes this a little bit of a challenging problem. But what I now know is that 7 pi over 12 is a combination of pi over 3 and pi over 4. And we'll make sure we get this right this time. It's cosine of pi over 3 plus pi over 4. So if I want to go ahead and write that formula down, cosine of u plus v, again, make sure that I have this right. This is a plus one this time. If I go back to my formula sheet, I notice that the cosines, they're both cosine, but this time the pattern switches. Where in the sine problem, it was supposed to stay the same. I just accidentally had the original formula as plus and our problem was minus. So we're going to do cosine of u, cosine of v. Again, it switches, minus sine of u, sine of v. So we'll put everything in here. Cosine of pi over 3 times cosine of pi over 4 minus sine of pi over 3, sine of pi over 4. And again, pi over 3 is your 60-degree angle. So if you need to see your triangle again. So we have cosine of 60 degrees, or pi over 3 is 1/2, times pi over 4 is root 2 over 2, minus sine of 60 degrees, or pi over 3, is root 3 over 2, times root 2 over 2. Finishing the answer, 1 times root 2 is root 2, 2 times 2 is 4, minus root 3 times 2 is root 6 over 4. We can leave our answer like this. We could write it as root 2 minus root 6 over 4. Let's do what the calculator did last time. The GCF is root 2, so we could factor out a root 2 and say it's 1 minus root 3 over 4. Any of these answers, including the decimal answer, just keep in mind you would not have the decimal answer if you didn't have a calculator. So let's check it. So again, my calculator's in radian mode, so I'll go ahead and just type trig cosine of 7 pi over 12. Press enter, and look, this time, let's see what they did. They have negative root 3 minus 1. So why they would do this, the factor the negative out, that was, if you distribute this back in, this would be negative root 6 plus root 2, which is what we have, negative root 6 plus root 2. They just, for some reason, factored out the negative instead. So we have an equivalent answer. All right, last example for the day. Find the exact value of the following. So this time, we need to look at this and recognize the sum and difference formula. So the question, as you're writing this down, cosine of 78, cosine of 18, plus sine of 78, sine of 18. So what we want to figure out is which one is it? Is it the cosine formula or is it the sine formula? And what you'll notice is that both of them are cosine, both of them are sine. So we know that this is the cosine formula. The next thing that we need to recognize is this is a plus. But with the cosine formula, they're opposite. So what we need to do is we need to take our u and our v, and we need to subtract them. So 78 minus 18 is the problem that you're asking. What is 78 minus 18? It's 60. So cosine of 60 is the problem. 30, 60, 90. Cosine of 60 is 1/2. So this entire problem without a calculator is 1/2. So that's using the problems in reverse, using the formula and going backwards, where the other one was using the formula going forwards. Let's just go ahead and real quick and double check that. If I type all that out, and again the goal was this, is that you don't have a calculator. So you have cosine of 78, and my calculator's in degree mode, so we want to make sure that I deal with that by putting my calculus in radian mode. We want to make sure that I deal with that by putting the degree symbol and cosine of 18, and again the degree symbol, get out of the parentheses there, plus, and we want to do the sine. So sine of 78, and get out of there, multiply by sine. It actually takes longer to type this than actually do the problem using the formula. And we can press Control Enter or Enter. Either way, what happened here? Let's see. I don't know if they did something fancy here, so let's hit Control Enter and see what happened. 0.5. So who knows what happened here? They did some, the CAS calculator did something crazy here, and the question would be, would all of this reduce to 1/2? And the answer would be yes, as I hit Control Enter. Okay, so this concludes the video, and I have my video lasting about 30 minutes, so if you had the sub pause the video, you should still have some time remaining to work in class. So the homework is going to be from both sections. We're going to do only 4 problems from the new section, but please make sure on 9 and 20 you don't worry about doing tangent. Our focus will be the sine and cosine for the most part, so you don't have to worry about doing tangent in those problems. Again, if I asked you anything from tangent, you would just follow the formula, just like we did with sine and cosine, even though I didn't do an example of that. The section 5.3 problems, like we saw today, are a little bit harder than the 5.3 problems that we did last class. Remember, those solutions are posted online. The sub should have already showed those today, but if you need to refer back to them, they will be there. So we will have a mini quiz next class. It's going to be 3 problems. The quiz is 5.1 to 5.3. I'm telling you right now, you're going to have 2 of your 5.1, 5.2 proofs and 1 section 5.3 solving. So make sure that you come in and see me if you need help on that, as I've told you on Monday. So go back and study your proofs, practice. It could be an expression, or it could be an equation where you have to prove the left side equals the right side, or it could be an expression where you just have to clean it up. And then solving. The solving problem would be the level of difficulty of day 1, not day 2. Okay, so this concludes the video. Again, you should have some class time, so it's my expectation that you use it. The sub does have my answer key to this homework, so at any time that you would need to see it, please ask the sub. Thank you.